Today we're going to revisit the idea of reduced echelon form of a matrix. Now you've used this in the past to solve systems in Algebra 2, and we will be continuously using this throughout linear algebra to help solve some problems. First thing we need to talk about is the elementary row operations. So there are three elementary row operations that we'll use in order to put things in reduced echelon form. First, we're allowed to multiply a row by a non-zero constant. So if for some reason, and you'll see the reasons why very soon, I choose to I can multiply any one of the rows by a non-zero constant. For example, I could take my last row and I could multiply it by a 2. So I could rewrite it as -2, 8, and 6. We're going to use this a lot. And then my other rows, I do not have to multiply. So those would stay constant the way they are. So that's our first row operation, elementary row operation. We're also allowed to switch any two rows. So if for some reason I wanted the last row to be first, I could just switch that with any of the other rows. So I could make it look something like this instead, where I have the -1, 4, 3 go first, and then I could have my 2, 8, 4 last, and I could keep my 0, 0, 5 where it is if I wanted to. So I can switch any two rows at any time that I choose. And the last thing that we're going to use is we're allowed to add a multiple of another row to some other row. So when I'm trying to eliminate things here, notice from back in this first matrix I wrote that if I were to now that I've multiplied the bottom row by 2, that if I were to add that to the first row, so I'm going to add the last row to the first row, notice my first row becomes 0, 16, 10. Again, I would leave my other two rows the way they are, and that's going to become real handy for us when we try to get some zeros in different rows and columns. What we're really looking to do here is we're trying to get the first non-zero entry in every row to be the number 1. So that's really important to us, that the first non-zero entry in every row is 1. This is called a pivot. We're going to use this word a lot in the future. A pivot is the only non-zero entry in its column, and rows are ordered to have any row that has all zeros on the bottom, and then they're ordered by their pivots. So one way that we want to have our matrix written might look something like this, where we have a 1, 0, 0. We could have a 1 here. Could be anything, depending on whether we have a pivot anywhere else. And maybe 0, 1, 0, 0. And then 0, 0, 1, 0. So here, if you were to look at our definition of a pivot, we have 3 pivots. 1, 2, 3. Because they're all the first non-zero number in each row. And also, if you look down or up, they're the only non-zero number in that column. So let's try to write this matrix in reduced row echelon form. So we know that we want to have a 1 in the first row, first column. Notice here, my second row has a 1 in the first column. So what I'm going to do is just rearrange this so that's in my first row, first column. So we could have something that looks like this. 1, 2, -3, using my elementary row operations. I'm just switching the row. And then I have 3, 8, -1, -4, 2, 1. Now what I need to do, in order for this to be a true pivot, I need to make sure that all of the numbers below it are 0. So I need to get both of these to be 0. So now I'm going to use the fact that I can multiply a row by any number and add it to another row to get a 0. So what I'm going to do is I'm going to take my first row. In order to get rid of this 3 first, I'm going to take my first row and I'm going to multiply it by -3. Then add it to the second row. Once I do that, it will get a 0 in the first row and column. So I have 1, 2, -3. Now I'm going to multiply again the first row by -3, add it to the second row. So my first term would be -3 plus 3 is 0. And then I have negative 3 times 2 is negative 6, plus 8 is 2. Then I have negative 3 times negative 3 is positive 9, minus 1 is 8. I'm going to do the exact same thing. I'll copy down the last row. Now I'm going to do the exact same thing for the last row. You could do it in one step. I'll write it in 2 different steps. So now I'll keep my first row the same. Rewrite what I just got in my second row. Do the exact same thing for the last row. So I'm going to multiply the first row by 4, add it to the last column. That way I get, or last row, excuse me. That way I get a 0 for this term. So 1 times 4 is 4, plus negative 4 is 0. 2 times 4 is 8. Add that to 2, we get 10. 4 times negative 3 is negative 12, plus 1 is 11. Negative 11, I believe. So that's what we have so far. Now, one last thing that you probably want to do before I show you the next step is you might notice that in this second row here, that both of the numbers are even. Remember, we said that we could multiply any row by a constant. So if I multiply this whole row by 1/2, then we end up with a 1 here, which is the next step that we're looking for. Here's my new matrix once I multiplied that second row by 1/2. So again, notice 1 is now a pivot. This is nice. We have zeros above and below it. Here, we want to make this one a pivot. So we need to have zeros above and below. So just like we did the first column, we zeroed out everything under the 1. Now we want to, in the second column, zero out the 2 and the negative 10. So, or I'm sorry, the positive 10. So let's do that. We're going to take the exact same steps as we did before. So let's work with this bottom row first. I want this 10 to become a 0. So what I'm going to do is use the 1 that I have, and use, again, the elementary row operation that I can multiply that by something and add it to another row to make that a 0. So I'm going to multiply this whole second row in my head by negative 10. And then add it to the bottom row. So I'm going to leave this the way it is, along with row 1. And then in my head, I'm going to multiply that by negative 10, add it to the bottom. So I would get negative 10 plus 10 is 0. 4 times negative 10 is negative 40, plus negative 11 is negative 51. So now we're going to do the exact same thing to get rid of the 2. Again, the beauty of this is I have a 0 in the first column here, so it's not going to affect that 1 that I had. I wanted that 1 in row 1, column 1. So what I want to do is cancel out that 2. So I'm going to multiply, again, in my head, this second row by negative 2 and add it to the first row. So this row stays the same. My last row is going to stay the same. And now I'm going to multiply again by negative 2. So 1 times negative 2 is negative 2, plus 2 is 0. 4 times negative 2 is negative 8, plus a negative 3 is negative 11. So this is great. This 1 is now a pivot because it is the only non-zero number in this row in this column. So now the last step is to get this a 1 to be a 1. Well, that's pretty easy because all we'd have to do is divide it by negative 55. I'm sorry, it should be a 51. Copy that wrong. So I'm going to divide that by negative 51, and then I get a 1 there. So that's what we want. Only problem is we have non-zero numbers above it. So again, what I'm going to do is I'm going to multiply this row by something to cancel out the numbers above it. Well, it's pretty easy. To get rid of the 4 that's directly above it, I'm going to multiply this row by negative 4 and add it to the row above. So then I'll get 1, 0, negative 11, 1, 0, 0, 1, 0. And let me just make that a little neater for us here. So we get a 0, 1, 0. Now, I want to do the exact same thing to get rid of the negative 11. So, to get rid of the negative 11, I'm going to multiply this bottom row by by positive 11, and add it to the first row. So once I do that, I get 1, 0, 0, 0, 1, 0, 0, 0, 1. Notice that the lead number in each row is a 1, and then that is the only non-zero number in each column. Exactly what we're looking for in row echelon form. Here's a problem for you to try on your own. Take a couple minutes, see if you get the answer, then go to the next video and check out if your answer is correct.